In this video, we will be discussing token ring. What is a token ring network? We need to answer this question first. What is a token ring network? A token ring network is a LAN in which all computers or hosts are connected in a ring or star topology and pass one or more logical tokens from one host to another. The definition which I just mentioned, I have noted down the key points. Now let's understand each of these points one by one. The first point is a token ring is a LAN. This implies that a token ring network will essentially be used for short distance communication. Next key point is the topology. The topology is either ring or star. So how does a ring topology look like? If you remember, a ring topology looks something like this. You have multiple hosts in the network, and every host is connected to two other hosts. See, I'll show you. Let me just complete the diagram. So I have four hosts in this. In fact, I have three hosts in this network. And if you notice, let's say this is my host A, this is host B, this is host C, and this is host D. I'm sorry, in fact, we have four hosts in this network. And we can see that every host, let's take host A. Host A is connected to host B as well as host D. Host C is connected to host B as well as host D. That means that a ring topology looks like this, in which each node is connected to exactly two other nodes. And what about star topology? In a star topology, you have all nodes connected to a central connection point like a switch or a hub. I'll show you. Let's say this is my central connection point. Let's say this is my hub. And to this hub, I'll have multiple nodes which are connected to it. I'll have multiple nodes connected to this hub. So a token ring network may follow either ring topology or star topology. And the last key point is that it uses logical tokens. Now, what is a logical token? A logical token is nothing but an empty frame. A logical token is nothing but an empty frame that travels around the ring. The direction, mind you, see, this is, let's say, our token ring network is using ring topology. Now what will happen is there will be an empty frame. There will be an empty frame, and this empty frame will travel across the network. Across this network, you will have this empty frame traveling. And one thing to note is the direction in which this empty frame will travel will be the same direction in which my data frame will travel. We'll see shortly that this empty frame will be used to avoid collisions. If a station wants to transmit, the first thing that it will do is it will get hold of this empty frame, which is also known as the token. And what it will do is it will carry out the transmission. After it gets hold of this frame, only then it can transmit data. So let's say station D wants to transmit data. What will it do? It will first get hold of this empty frame. After it gets hold of this empty frame, it will transmit data. So transmitting data will involve a pre-processing step, which is nothing but getting hold of this token. Since one station will be getting hold of only one token, collisions will not take place. See, station D wants to transmit, so what it will do? It will get hold of this token. Now, if station C wants to transmit, it will not be able to do so. Why? Because the token currently belongs to station D. Only after station D relinquishes, that means lets go of this token, only after station D lets go of this token will any other station in this network be able to carry out the transmission process. So I'll list out the steps in a few minutes from now. The last point that I want to mention before I go into the working steps is that a station can transmit only after it gets hold of the token. You please keep this in mind. Now the working steps are as follows. So I'll just write down the working steps. The working steps, see, the first working step is Systems in the LAN are arranged in a logical ring. We just saw it right now. Now each system receives data frames from its logical predecessor on the ring and sends them to its logical successor. That means I'll draw the network again, the ring topology. So I have multiple hosts, right? So this is my host A, this is my host B, this is my host C, and this is my host D. Now all these hosts are connected to one another in the form of a ring topology, right? What will happen is systems in the LAN, that means this entire systems, this entire collection of systems, they're arranged in a logical ring. Now each system, let's say station A, for example, will receive data frame from its logical predecessor, that means station D, and from its logical successor, which is station B. Now it can be, now here I mentioned that D is the logical predecessor. It may so happen that the station B may be the logical predecessor. So the predecessor and the successor, that depends on the direction in which your data frame is traveling. That means if the direction of flow is this way, then the predecessor of station A will be station D, and the successor of station A will be station D. See, I'll repeat again. If my data travels in this direction, the direction in which the arrow has been drawn, if my data frame travels in this direction, then A's successor, in fact A's predecessor is D, station D, and A's successor is station B. Okay, I hope this point is clear. Next point is any node. See, any node, point number 2 is any node which receives an empty frame and has nothing to send simply forwards the empty frame. Now what is this empty frame that we are talking about? This empty frame is nothing but my token. We use the term empty frame and token, we use it synonymously. So if a station, let's say station A receives the empty frame and it does not want to transmit any data. So what it will do is it will simply pass on the frame. If a station, any of the stations in my network, if they do not want to transmit data and they end up receiving the empty frame, then they'll simply forward the frame to the next station, to the successor. That means if A receives the empty frame and it does not want to transmit, then it will simply forward the empty frame to its successor, which in this case happens to be station B. And what if a station is the intended recipient? Then what will happen? We'll see that shortly. We'll see that in step number 4. So in step number 2, we can understand that a station which does not want to transmit, a station having nothing to send, simply forwards the empty frame. So this was step number 2. And what about step number 3? Now step number 3 says that when a computer has, or when a host has a message to send, it waits for the frame. See, if any of these stations, if they want to send a frame, what did I mention? I had clearly stated a while back that if a station wants to transmit, the first thing it must do is get hold of this empty frame, get hold of the token. Only then will it be able to carry out the transmission process. So when a host has a message to send, it waits for the frame. When it gets hold of the frame, it does the following. See, let's say station A wants to transmit. The first thing that it will do is it will wait for the empty frame. Once it gets hold of the empty frame, it will carry out the following steps. The first thing that it will do is it will indicate that it is sending data in the frame. So it will indicate that it is sending data. Indicate that it is sending data in the frame. Now how will it do this? It will do this, see, this empty frame which I have, you can visualize it in this way. The empty frame which I have been talking about for some time now, this empty frame. which is sometimes also called the token, this empty frame has three parts. This empty frame has a part called the token, it has a part called the payload, and it has a third part called the destination address. Now, if a station wants to transmit, first thing that it will do is it will get hold of this entire empty frame and it will make a change to this token field. Now, what kind of change will it make? If my empty frame, or if I put it this way, if I have this frame and it is empty, then probably all bits in this entire frame will be zeros. Now, one way of indicating that a particular station has got hold of the frame is by changing the bit pattern in this token field to something else. That means if the bit pattern in this token field, if it happens to be a simple 0. So this is my empty frame and the token field there is a 0. A station wants to transmit. What will it do? First thing it will do is that it will indicate that it is sending data in the frame. One way of doing it is simply flip the bit present in the token field. So it will change this 0 to 1. The moment it does this, the other stations, once they get hold of the frame, they'll understand that this token has now been captured, and if they want to transmit data, they have to wait. They have to wait for the current transmission to get over, and only then it can carry out the transmission process. So the first thing a station does is it indicates that it is sending data in the frame. The next thing that it does is it inserts the data. It inserts data in frame. And where does it insert? It inserts the data in the payload section. So the data that a station wants to transmit, that data will be inserted in the payload field of the empty frame. And the third step is to insert the destination address. Of course, if a station wants to transmit, it probably wants to send the packet to some other station, right? So what it will do is it will simply fill up the destination address field with the address of the receiver. That means if station A, let's say station A wants to transmit a packet to station C, it will simply, in the destination address field, it will simply put the address of C because it wants to transmit to C. If it wanted to transmit to D, then it would put the address of D. If it wanted to transmit to B, it would put the address of B. If it wanted to transmit to some other station, which I have not shown in this network, but is a part of it, then it would put the address of that field. So I hope this step is clear. So I'll just sum it up again. If in step 3, what happened was a station wanted to transmit data, and what it does is when a computer has a message to send, it waits for the frame. When it has one, it does the following. What is the first thing that it does? It indicates that it is sending data in the frame. How does it do so? By changing the bit pattern in the token field. The next step is it inserts data in the frame. How does it do so? It simply changes the payload field with the data that it wanted to transmit. And what is the third thing that it does? It will set the destination address or the destination identifier in the empty frame. What about the fourth step? The fourth step pertains to the receiver. When a host receives a frame containing data which is indicated by the token, it knows it cannot transmit data. And so it does the following. If it is neither the sender nor the receiver, it will forward the packet. That means what happens is, see, let's say a host receives this frame which has been populated with a lot of information. Let's say a host which is neither the sender of this frame nor the intended recipient of this frame, it receives this frame. Of course, it may happen, right? Why not? It can happen. Let's say station A wants to transmit it to wants to initiate a transmission process with station C. So what it will do is it will get hold of the token and it will fill up these details in the empty frame. By empty frame and token, I mean the same thing. As I mentioned in step 2, that empty frame and token, they are used synonymously. So if a station wants to transmit, A wants to transmit, it will first get hold of the empty frame and in the empty frame it will fill up the necessary details. After it fills up the necessary details, if you observe the network topology that I have drawn here, A is not directly connected to C. A is connected to B and then B is connected to C, or A is connected to D and D is connected to C. Considering the flow of information in this direction, A has to first transmit this filled up frame, this is no longer an empty frame, this filled up frame to station B, which in turn should transmit it to station C. Why? Because B is neither the intended recipient. How does it understand that? It understands that by looking at the destination address. The first thing that B sees is the token field. Once station B sees the token field and finds it to be of a different pattern than that of an empty frame, it understands that it cannot get hold of the token now, because somebody else, some other station has initiated a transmission process. The next thing that it checks is that, is it the intended recipient? How does it check that? It checks the destination address. If it finds the destination address field to contain the address same as that of itself, then it will understand that, okay, this frame, or there is a station somewhere in the network which wants to initiate a communication with me. Then it would start that communication. But if it finds that the destination address field contains an address which is not the same as that of itself, here, like in this case, the destination address contains the address of C, but the address of B is not the same as the address of C. That means it is neither the sender nor the receiver. So what should it do? It should take this empty frame and simply forward it to the next node. And which is the next node? The next node is C. So what should C do? C should check whether it is the receiver or not. But again, just like B, the first thing that C will do is it will check the token field. And once it finds that the token field has changed from its initial value, it will understand that it cannot get hold of the token now, and it cannot play the role of the sender now, because some other station in the network has taken up that role. Some other station in the network wants to transmit data. Next thing that it will do, just like B did, it will check the destination address. If it happens to be the intended receiver, it will simply copy this message, this data. This data may also be known or may also be called the payload or the message. So C will copy this data or the message or the payload, whatever you call it. It will copy the message from this frame and it will clear this token field. See, the token field, which was initially 0, was set to 1 to indicate that a transmission process has begun. Now, once the frame reaches the intended recipient, the token will again be reset to 0. So C, my station C, will reset the token field to 0, and this will indicate that the frame which was intended for it, it has already taken the data part of that frame. I'll repeat once again, by resetting or by clearing this token field, station C ensures that the data part of this frame has been copied to it. It is the intended recipient. What is the job of the intended recipient? To get hold of the data part, and that is exactly what it does. After it copies the data part, after it consumes the data, after it consumes the message, it will reset the token field, and this will be an indication that data has been successfully transmitted from the sender to the intended receiver. And now what will happen? Now the token, this frame, this entire frame will be circulated. So C will transmit the frame to D. Now D, on receiving this frame, will find the token field to be reset. Okay, the token field is clear. So D will understand that, okay, maybe I can carry out a transmission process. Why? Because the token field is clear. But then it will find the payload field to be containing some value, to be containing some data part. Then it will understand that, okay, this is a case where there was a transmission process in which the receiver has consumed the data and is now acknowledging that and sending it back to the sender. That's why station D cannot initiate a new transmission even though the token field is reset. So station D will simply forward the token to station A. Now station A again will do the same thing. It will first check the token field. It will find it to be 0. So it thinks that it can carry out or it can initiate a transmission process, but immediately on checking the payload part, it will find that okay, the data part has been copied. See, the token field. See, you have to understand one thing. Station A was the initiator. Since station A was the initiator, it will be expecting this token back to it. So once it finds this frame, once it finds this entire frame, once station A receives this entire frame again and finds the token field to be cleared to 0, it will understand that okay, the transmission process which I had initiated for station C has been carried out successfully. Since it has been carried out successfully, what will station A do? Station A will clear this payload part. What it will do is, it will reset the payload field to all zeros, indicating that the transmission is complete, and also it will reset the destination address field to all zeros, indicating that the transmission is complete. In this way, what will happen? The frame which was empty at the outset and then got filled up with data has again been converted to an empty frame, and it will again be circulating throughout the network so that any other station which wants to carry out a transmission process may do so. Okay, so this was a long video. There was a lot to explain regarding token ring. I have gone into as much details as I possibly could, but if you think that I have missed out some point, or if you want me to elaborate on some other point or on some topic or not topic, if you fail to understand, or if I was unable to make you understand a point or two in this video, please feel free to leave your comments in the section below, and I'll definitely get back to you. I hope this helps. Thank you.